It's no secret that modern web development has become insanely complicated. And while these modern frameworks are really good at what they do, you often don't need a modern framework to get a lot of tasks done. So introducing the Goth stack. Now the Goth stack features a very simple backend language being Go, and it also features a simple templating language and HTMX for interactivity. And we've also got Tailwind in there for styles. So this video is going to be a code walkthrough that's going to get you set up and running with the Goth stack really quickly. So if you have a look in the description below, you'll see a link to the GitHub repository and you can clone the Goth stack from there. So the first thing we're going to do is go through the file structure, and I'm just going to explain a little bit about why things are where they are, and as you're developing, where you're going to put your different components. Then we're going to dive into the code, and then finally, we're going to run it, and we're going to have a little demo. So the first folder that we're going to include is our CMD folder, and this is just going to include our main.go. The second folder is going to be the internal folder, and this is where you're going to do most of your work. So inside of the internal folder, we have auth. Now auth only includes one package at the moment, and this is token auth. And token auth has some handy functions for creating a token and validating a token, and that's it. You'll notice a pattern in this file structure, and one is that you'll have the folder name, and then inside of that folder, you'll have a file with the same name, and then you're going to have some other folders inside of that folder as well. The reason that we do this is because if you have a look in this auth.go, you're just going to see an interface for the packages. So we have one package, and that's token auth, and then we have an interface for this. So this is something that's going to be repeated throughout the code base, and this is going to make it super simple for you to write tests for your features. So now whenever you have something that uses token auth, you can pass in this interface, and now you can mock it, or you can pass in a real struct, just something that satisfies this interface, and that's going to be very simple for you to then test that. The next folder is going to be our handlers, and these are our HTTP handlers. So these are going to be the handlers that handle all of the requests to the application. So the files are prefixed with their method. So you'll see here, this is get about, and then we have post login. So the reason that I've done this is because there's two different scenarios in terms of HTTP here. One is I just want to make a request to the homepage and I want to render a layout. Then the other is that I want to post some data back to the server and I want to get some hypermedia back. Because we're using HTMX, we're going to return HTML. So I've just prefixed these to give you a good indicator about what it is that this is going to do. So if it's prefixed with get, then it's probably just going to render a template and that's it. If it's prefixed with a post, or you might have some puts in here, then it's probably going to have some more interactivity in here. So you can see the post login handler is going to do a bunch of stuff in terms of login. So I can get into this rendering stuff just a little bit later on after we've gone through all the files. Okay, so the next is our middleware, and our middleware is just going to have two pieces of middleware in here at the moment. One is our CSP middleware, and this is going to add some CSP headers for us, and this is really important in terms of security. So you can see that we're creating 3 random strings here, and then we're going to add those 3 random strings to context, and then we're going to add a CSP header or a content security policy that tells the browser what scripts and styles that we can run. So there's one other thing to note here, and I'll point it out now because otherwise it might be confusing. This CSS hash here is a hash of the CSS that HTMX generates. So when you run HTMX, it's going to inject some CSS into the page, and this is the hash for that CSS. And then we're going to add this to our CSP header so we can tell the browser, yeah, it's okay to run this CSS. The next middleware we have is some text handle middleware, and this is just going to set the content type to text HTML. And the reason that we do this is because we're using HTMX, therefore we're using hypermedia, and we're not going to be sending JSON out to the client. Okay, so the next folder that we have is our store. Now, in your application, you're probably going to want to have a database, but I don't know what database that's going to be. It could be Mongo, it could be Postgres, it could be Redis, it could be CockroachDB, it could be anything. And I don't want to put you in a box of using a specific database. I want you to be able to take this Goth stack and use it however you like. So I've made a generic database package, And this is just going to be an in-memory database. And you should take this package and then you should inject your own database. And then you can start using that database as you need to. Okay, so we have this store interface here, and we only have one store at the moment, and that is going to be our user store. And you can tell by now, and we haven't even looked inside of DB store, you can tell that our user store has two methods on it. It has a create user and it has a get user. So whenever you add a new store here, let's say you're making a CRM and you have a project model in your database, then you'll want to have a project store. And in here, you'll want to create an interface for that project store. And you'll want to define all of the types, like the project inside of this store. And you can define, let's say you're using Mongo, you can use your BSON tags here, and you can use your JSON tags, although you probably won't need to use JSON. And you can define all of that here in this store package. Now, when we go into DB store, you can see this is part of the package DB store. You can create your function to return a new store, and you can create your store type. And then you can have your methods in here that satisfy the methods in your store. So this is another pattern that you're going to see throughout the Goth stack. One is we have a struct, and then that struct is going to have all of the properties on it that you need, and users can actually be lowercase. We don't need to export that. And then on that struct, we're going to have some methods. So if you wanted to change this to use a real database, let's say you wanted it to use Mongo. In this user store here, you would have your collection, and this would be a Mongo collection, and you would inject that into the user store. I'm a big fan of dependency injection. I think it makes testing way simpler. And then you could start using that collection down inside of your methods here. So another thing to note is when we create a new store here, we're just creating one user in our in-memory database, and that is going to have an email of one, an example, and a password of password, and that's so we can start logging into the application straight off the bat. We don't have to register a new user every time we restart the application, because we're going to see later on that whenever we change a file, the application is going to restart automatically. Okay, and then finally, we have our templates, and our templates consist of two different types of files. One is going to be this about templ.go, and this is generated code. This is generated by Templ. So it says here, do not edit, and that's right, don't edit this. What you do edit is this .templ file here. So .templ is going to include this templating language, and the Templ docs are actually really good. So I'm not going to go too much in how to use Templ because you can just simply read the docs and they're going to explain it much better than I can. But basically you have a function here and you return some HTML. It's actually that simple. And you're going to see some examples later on of where you can create layouts and stuff like that. Actually, let me show you that now. So I have this layout here, and in our layout, of course, we need a header, we need a footer, we need some navigation, and then we can have our layout. So our layout is going to include our header, our nav, and our footer. So to render, so this @ header here just references this header template up here. And then finally, we have our contents, and that's going to be inside of our main here. So the last folder that we need to know about is going to be static. So static includes two parts, our CSS and our scripts. So inside of CSS, we have this input, and this is going to be our Tailwind input. And when we run our Tailwind compiler, it's going to look at this file and it's going to look at all of our templates, and it's going to figure out what CSS it should write. And when it writes that CSS, it's going to write it to this style.css. So this style.css here, you won't ever need to touch this. This is generated automatically for you by Tailwind. Next is going to be our scripts. So this first script is, of course, HTMX, and this is a minified version of HTMX. Again, you don't need to touch this. The next script that we have is going to be our response targets. So response targets is an extension of HTMX, and this is going to allow us to use an extended response targets. So we can have a response target for when the server returns a 401, for example. So if the user fails a login, then we can update the text somewhere based on that 401. And I'll show you how to use this response target. It's very simple. The docs are also very good. Then we also have some other files in here. The first one is going to be our air.toml, and this air.toml basically is a configuration file for a program called Air. And Air, if you're familiar with Node, is like NodeMon. It allows you to start your application in a watch mode, and then when you save a file, it's going to restart the application. We have our go mod and sum, of course. Then we have a make file. So this make file is going to include a bunch of commands that are really helpful for your development. So one is going to be this dev command, and this is going to run the build command. It's going to build into this temporary directory here, and then it's going to run air. And air is going to repeatedly build that whenever you save the file. Next, we have a build command, and this is going to run our Tailwind, and it's also going to run our Templ generate. So Templ generate is going to output these templ.go files here. And then it's going to build our application. Next, we have some Tailwind configuration. So this is just normal Tailwind configuration. You can put any Tailwind config in here that you like. It's telling it to look inside of internal and templates for Templ files to figure out what classes it should generate inside of the style.css. Okay, and the next file we have here is our Tailwind CSS. Now, if you're on an ARM64 Mac, then this is going to work perfectly for you. You won't need to change anything. If you're on any other computer, you're going to need to download the binary for your operating system. So in the README, you'll see a link to this standalone CLI. So let's open that. So you'll see here, this is a getting started with the standalone CLI. So by default, it has the macOS ARM64 version, but if we come over to the latest releases, you can see there's a bunch of different releases for different operating systems. So if you're on Windows, for example, you're going to download one of these Windows binaries here, or the executables. And then you just need to rename it into tailwind.css, and then you can execute it. So you should then be able to execute it with the make file as usual. Okay, so let's start walking through the code so we can get a more in-depth view of how this thing works. So let's go into our main.go. And the first thing that we'll note is that we're using GoTTH. So you can replace this with any HTTP framework that you like. I personally like GoTTH because it's super simple and it doesn't add many things that are GoTTH specific. So you'll see the handlers. If I have a look at one of these handlers, it's basically just a HTTP handler where you have your response writer and your request. There's no specific chi object that you pass into these. And that's one thing that I really like about chi. Okay, so we're going to first create a logger, and we're going to use the new structured logger. And I'm not sure what version of Go this was available in, but if you don't have access to the structured logger, then you'll probably need to use a new version of Go. We're going to create our new router, and then we're going to register our user store, and you're going to register any other store that you have. So register stores. And the reason that we register these in our main is because we can then go inject these into the handlers as we need. Next, we're going to create our token auth. And again, this is so we can start injecting this into the handlers as we need. So you'll notice here that we're using a secret, and so there's two things to note here. One is you shouldn't do this. You shouldn't use an algorithm that takes a plain text string for your JWT signing algorithm. You should use something like RS256 that takes a public and private key. And then secondly, you should store this in configuration, but we don't have any configuration yet. If you do want that, then feel free to make a pull request, or I can add it in if enough people want that. Next thing we're going to do is to create a file server, and this is so we can serve out our static content, so our CSS and our JavaScript files. The next thing we're going to do is to create a group of routes, and then we're going to apply these middlewares here. So we have our logger, we have our text HTML middleware, and remember this just adds a header to set the content type to text HTML. We're going to add our CSP middleware, and this creates some CSP headers as you saw before. Then we're going to add some JWT verify function as middleware, and this is so we can use the user inside of our handlers automatically. Then we're going to register a bunch of routes, So a route that is interesting is one that has some things injected into it. So you can see here this login route. So what we're going to do is we're going to listen to /login. Then we're going to call the new login handler function. We're going to pass in some params, and then we're going to pass in some dependencies that that handler might need. So one is the user store and one is token auth. So this is what I mean when I say dependency injection. This handler has a dependency and we're injecting it instead of just requiring it or importing it straight from its package. The reason that I like to do this is because you can create a test file for this handler. And by the way, this has no tests, and I'm a big fan of tests. And so if you want me to start adding tests, then I can. But my assumption is that you're not going to use the code that I have specifically here. And so it's just another thing for you to remove. Yeah, so the idea is that you can create a new handler in your test, and then you can just inject mocked versions of these stores here. Okay, so the next thing we're going to do is to create a channel, and this channel has a size of 1 and it has a type of OS signal. Then we're going to listen for kill signals. If we get one of these kill signals here, then we're going to inject that into the channel. And you can see down here, we're just going to block the rest of the program until we receive something on that channel. So if we do receive something on that channel, it's because we've received a kill signal and we should begin the shutdown process. So you can see we get a message here. We're going to set some context, and this context is going to be 5 seconds. And this is just going to tell our server, you've got 5 seconds to shut down. If you don't shut down within that 5 seconds, then we're just going to exit with a status code of 1. Otherwise, we're just going to exit the program as normally. Okay, so let's go back up. You can see that we're setting a port. Again, if you want this in configuration, let me know. We're going to create a HTTP server. Then we're going to listen and serve on that server, and we're going to do this in a Go routine so we don't block the application right here. So you need to block the application from exiting at some point, and this point that this application blocks is with the kill signal. Otherwise, it would be the listen and serve function that's going to block. Okay, so that's the main. Let's go into the handlers and have a look at how they render templates. So we'll have a look at a really simple one first. This is just to render the about page. So you can see here, we're calling templates.about, and templates.about is because we've put this in the package templates. So if you call this package something else, let's say you called it goth, then it would just be internal/goth, and then this would just be goth.about. I've also seen some people put these in their main package. I'm not sure why you would do that. I guess it's so you can reference it anywhere, maybe. I'm not sure. Okay, so we're going to execute that template, and then we're going to get a Templ.component back. And instead of just rendering that component out, we're going to wrap it in a layout. So I'm going to say templates.layout, and remember we had a look at this layout template earlier. And we're going to pass in a title. And so layout here, you can see takes a component and it takes a title. So we're passing in our component here, and our component is the about page, and our title is my website. Then we're going to call .render, and we're going to pass in our request context, and we're going to take in our response writer. So it's then going to render this template and pass it on to the response writer so we can respond to the user with some HTML. And then of course, we're going to catch some errors. This error handling here, there's probably something better we can do. I don't think we just want to return a 500 error if the template doesn't render properly. Maybe we want to try render a backup, an error page, or something like that. I'm not sure, but I'm open to ideas here. Okay, so let's have a look at a more complicated handler. So this is the login handler, and there's a few spelling mistakes, which is fine. I can fix those up. So we're going to get our form values here. Then we're going to try get the user from our store. If we have an issue getting the user, we're going to render a template. So this template is login error. So we have a look at the login template. You can see that I've created the login page template, But I've also included a template for login errors. And I think this is kind of a good pattern. So if you wanted to include any other template that belongs to login, I think this login Templ file is a good place to do that. I think it's probably okay to couple these templates like that. Okay, so we're going to render out the login error, and login error is just a p tag basically. And then we're going to hot swap that into the login error div. And I can actually show you that in the login page. Okay, so remember earlier I said that we're using the extension response targets. We have to put at the top of our page or the top of the component somewhere has to be this HX extend, and then we want to put response targets in here. If we remove this, then our response targets extension won't be applied to this page. Then if we respond with a 401, then our target is going to be this login error, and we have a div here with login error. So if we respond with a 401, we're going to get the body of that response, which is going to be this HTML here, and we're just going to pop it into this div here. So that's how we're going to show error messages to the user. Then we're going to try verify the username and password. This is a very simple verification process. There's no hashing or anything. The password is just stored in plain text. Of course, you want to change that. Then if they do match, we're going to generate a token, and we're going to set a cookie and all of that good stuff. Then we're going to use this HX redirect. So this is a header that we're setting. And then this is just telling HTMX, when you get this header from the response, do the redirect to the path that's supplied in the value. Otherwise, we're just going to render the login. So they've got their password wrong, and we just want to render the login error, which is invalid email or password. Okay, so let's go see this in action. So we can open up a terminal, and if you're confused about what you might run, so there's two places you can look. One is going to be the README is going to give you a bunch of commands that you can run. And then the next thing is going to be the make file. So you can see here we have a dev command. So we can say make dev. So you can see that our server has started successfully, and we can go over to a browser and we can look at this port 8080 and see what we get. So we get a very simple page here. We get our footer down the bottom here. We get our header, and we just get this welcome guest. So we can click on login, and I can get this wrong. So I can say something at something.com. I can pass in a password that's obviously wrong. Click sign in. And you can see we get this error message here, invalid email or password. Again, this form is very ugly. I know that. That's okay, because my guess is that you're probably not going to use the HTML that I put in here. And so I don't want to make it super confusing to remove a bunch of classes and all that sort of stuff. I just want to make it very simple for you to make this how you want it. Okay, so we know when we start the server, we get one user, and that is one at example.com, and their password is password. So we can put that in, click sign in, and you can see now we get a welcome one at example.com, and we can continue to click around. The reason that it knows who we are, so we can refresh here a bunch of times, and you can see that it still knows who we are, is because we have this access token here, and we have some middleware to look at that access token, and it's going to verify that we are who we are. It's going to read that access token and verify it, and then it's going to put the user inside of context so we can use that. And I can show you that now. So if we come over to the index template, you can see that we have two indexes. One is just our normal index that says welcome, and we have an email that we've injected here. The second is just going to be our guest template, and that is just going to say welcome guest. So let's go have a look at the handler for this, and this is going to be get home. So you can see that we're trying to get the JWT claims from context. And from those claims, we're going to try get email, and we're going to cast that to a string. And if this is not okay, if we can't get email out of the claims, then we're just going to render the guest index here. So you can see we're doing this thing where we get the component and then we pass it into a layout. Otherwise, we're going to render the index with email. Okay, so I think the last thing is, what if we change one of these templates? What do we do? How do we regenerate these? So let's say that guest now takes a title, and that title is going to be a string, and we just want to render the title. So string. So you can see that we try render the guest template and Go isn't complaining. It doesn't care. We've put a title on here and it's missing, but yeah, Go just doesn't care. So how do we make Go care? Well, we have to run make, and I actually forgot the command. So I'm going to have a look at my make file. And it's going to be Templ generate. So make Templ generate. And then this is going to generate the templates again. We can go back to our handler and you can see now that Go is complaining that it wants one string here and we gave it none. So let's remove that. And we can regenerate the templates and then Go will be happy now. So what about styles? What happens if you're changing your styles and you don't see them reflected? Well, there's one of two things that you need to do. One is you can watch Tailwind watch, and this is going to run the Tailwind binary inside of a watch command. And so every time you change a style, it's going to regenerate your styles for you. Otherwise, so if you're just developing normally, you'll want to have this watch command running in the background. Otherwise, you can build the styles, and this is going to build a minified version of the styles. So you'll want to run Tailwind build. If that doesn't work, remember you need to use the Tailwind binary that is suited for your operating system. This Tailwind build command here, you probably won't need to run that manually because it's included inside of the build command here. The last thing I want to show you is if we have a look at the view page source and we zoom in a little bit here, and we can scroll across, you'll see these things inside of the HTML called nonce. And if you're British, you might find this a little bit funny. And it's just this random string here. And this nonce here is generated by that CSP middleware that I showed you earlier. And this is just going to tell the browser, when you see a JavaScript file with this nonce, you are allowed to execute that. The server has said that this is the file that we expect you to execute. There's nothing being injected here. And the reason it knows that is because if we come over to our network panel and we refresh, we can have a look at localhost here, and let me zoom in so you can actually see. And we should have a header here, content security policy, and you can see that we have a script of nonce 7 blah, blah, blah. Let's copy that and then find that, and you can see that matches our script here. We'll also have, we'll have two because we have two scripts. And we'll also have one for our styles. And then we'll have the hash for the styles as well. So that is a basic overview of the Goth stack. If you like this video, please make sure you leave a thumbs up. If you use the Goth stack, please make sure you go over to GitHub and give a star to the repository. And let me know in the comment section below what you think I should add or change about this stack. Thank you for watching, and I'll see you in the next video.